2-4 writing linear equations. So this lesson is all about how to write linear equations using different forms. So first, let's talk about slope-intercept form again. Talk about briefly last lesson. Now let's go deeper into it. So as I mentioned, you solve for y. The thing next to your x, the coefficient next to your x is your slope, and then the constant is the y-intercept. Now they also mean other things. So remember, slope is another way to say rate of change. A lot of times you see that as a per. You see the word per. You're talking about the slope. Y-intercept is also known as your starting value, because your x is 0, so this is your starting value, or initial value. Or the constant, right? Like the stuff that you can't get rid of, the one that you're going to have no matter what. So we're going to use these more when we talk about application problems. So there's some right here, just how to graph, and we'll talk about that more in a bit. But right, slope, y-intercept. From your y-intercept, you do your slope. This is the application problem to get us started. The number of students in a graduating class loses about 12 students a year. The latest freshman class had about 400 students. Find the following. So when we write an equation of number of students in a given year. So keep in mind it loses about 4 students per year, right? Students a year or per year. So if I'm writing an equation for this, I'm going to do y equals mx plus b. And this is going to be my m. Now I lose 12 students, so m is actually equal to negative 12. And I start off with, my first class has 400 students. That's our starting value, so that's our b. So if I'm writing this equation, y equals negative 12x plus 400. Where x is the number of years, and y is the number of students. Now if you want, you could get more fancy. You can make like that be s. You could change the variables around, like the year, so let this be like time. But it all means the same thing, right? This would also work, right? Where t is time and s is students. However you want to use it. Find the number of students in the senior year. So this would be senior before. So that's going to be years, so that's going to be our x. So let's plug it in. Negative 4 times 12 is negative 48 plus 400. And I get 352 students. So start of senior year is only about 352 students. We start with 400. So that's how we're going to use slope-intercept form when we write equations. If we see that they're giving us a slope and a starting value, then we want to put it in the slope-intercept form. Now the thing that slope-intercept form is most famous for is graphing. So let's review that. So I want to graph this. Now step 1 is let's put it in slope-intercept form. So try to get y equals. So in this case, let's subtract 3x from both sides. I'm going to get negative 2y equals negative 3x plus 8. And then we're going to try to get y by, so let's divide everything by negative 2. Remember, divide everything by negative 2. And I get y equals 3x over 2 minus 4. So that's my equation. Now, in this case, my slope, right, it's the thing next to the x, coefficient, 3 over 2. And my y-intercept, my b, is negative 4. Now this is where we start. That's my y-intercept. That's 0.0, negative 4. We start here. So on your y, you go to negative 4. That's your first point. And then from that point, we're going to do the slope. So I get 3 over 2. Now we're going to treat it as rise over run. Right? Rise over run. So remember, we go up when we rise. If it's a negative, we go down. And we always go right. So from here, I'm going to go up 3. 1, 2, 3. Then I'm going to run 2. 2 to the right. Always go to the right. Connect the dots. And that's the slope. So that's how we graph, right? You plug in the slope-intercept form, the y by itself, and now you know what your slope is, you know what your y-intercept. Search your y-intercept, and then go with the slope. So that's graphing the slope-intercept form. How about when you go backwards? What if I give you a graph and I go, hey, what's the equation? So in this case, the easiest way to make an equation if I give you a graph is to use slope-intercept form. So all we gotta do is find two things. We gotta find the slope, and we gotta find the y-intercept. Now y-intercept is easy, it's right here. 6. Now we gotta find the slope, right? Now, how about this in the last lesson? The way you find a slope is you find 2 points that cross nicely. So that one right there works. 0, 6. And you gotta find another one that crosses nicely right here. -6, 2. Now you could use a slope equation. There we go. Right? Or you'll see right to run. I went over 6, right? And it's positive, went to the right, and I went up 2, up 4. So I went up 4 over 6. So my slope, rise over run, would be 4 over 6 or 2/3. So putting this equation, that's 2/3, and that's 4. So my equation is y equals 2/3 x plus 4. So that's how you write an equation if I give you a line. If I give you a line, easiest way to write an equation is this slope-intercept form. Find the slope, find the y-intercept. Now, if I don't give you a line, or is there another way to doing this? And there is, and it's called a point-slope form. Most of the time, point-slope form is going to be the easiest. I was supposed to highlight that. It's supposed to be the easiest way to find an equation. It's point-slope form. There you go. Didn't mean to erase all of it, but whatever. So point-slope form, it's this right here. Y minus y1 equals m times x minus x1. The benefit of point-slope form, it makes it really easy to make an equation. Easy, that's an S, to make an equation. Because all you need is, like the thing says, the point, x1, y1. So that's right here and here. And you need a slope. M. So it goes right there. So if you have a point, any point, and you have a slope, then you can write this equation. Just to show you, let's go back up here real quick. Right, if I want to fill out this equation, try to find some space. Let me do it over here. Right, all I need is a point. We have a point right here. 0, 6, so plug in 0 for x, and 6 for y. And then you need the slope, which we found is 2/3. So you get y minus 6 equals 2/3 x minus 0. Now, if I don't say put in slope-intercept form, you could just leave it like that. But if you could, you want it to look the same, you could distribute. And you get y equals 2/3 distribute x plus 6. And they should match. Oh, I'm sorry, I'm done. That's 6. Why did I put 4? 6. Okay, so now they match like they should. That was wrong earlier. Oh, that's embarrassing. So anyway, so it works both ways. So in general, when I want to make an equation, I do point-slope form. Only time I don't do it is if I have a line. If I have a line, it's actually a little easier to do slope-intercept form. But if I ever say write an equation of a line, if you see these words, you want to think y minus y1 equals m x minus x1. It's the easiest way to make an equation. So let's do a couple examples of that. So the first one, slope of 4 passes through 6, 9. They want me to write an equation, so I'm going to write this down. Now they want a slope of 4, so I have a slope of 4, and it passes through points 6 and 9. So this is 6 and this is 9, and you are done. Unless I specifically ask you to put in a certain form, like I could say put in standard form or put in slope-intercept form, that's an answer. If they just want an equation, you're done. Now if they say put in slope-intercept form, then you have to distribute. Again, only if they ask. And then you have to add 9 on both sides, and you get this. It's 15. And again, if you want it in a standard form, just move the 4x over and you get standard form. So that's slope-intercept form, and this is standard form. Right, so standard. This is fine 90% of the time. If they ask for a very specific problem, just simplify, do some math, and get your answer. Let's do another one. Find the equation of a line with, and again, anytime I see those words, I write this down. Y minus y1 equals m x minus x1. Now, again, I need a point in the slope. I have 2 points. Let's say x1, y1, and x2, y2. I have no slope. Well, let's find the slope first. There's an equation for that. Plug your values in. 6 minus -6 over 4 minus negative 2. A lot of double negatives going on here. I get 12 over 6, or just 2. So that's my slope. Now it doesn't matter which points you plug in for x1 or y1. It does not matter. I'm just going to keep it simple. Now notice I always plug in for x1 and y1. I don't plug in for x and y. X and y, you always have an x and y in your equation. So just plug in for x1 and y1. Negative 2 and negative 6. Double negatives again. So I get y plus 6 equals 2x plus 2. And again, it didn't say put in slope intercept form or whatever. I'm just going to leave it like that. That's fine most of the time. Okay, let's talk about special types of lines. First up, parallel lines. So as you guys learn in geometry, parallel lines are lines that never cross, and they have the same slope. So if you look at these two lines that are parallel, slope here is 2, slope here is 2. So if I tell you, hey, the slope of this thing is 3, you're going to be like, oh, the one that's parallel to it is also going to have a slope of 3. Right, same slope. So let's do an example. Write an equation of a line that's parallel to this and goes through the point this. So again, my first idea is, hey, equation of a line, y minus y1 equals m x minus x1. Now they gave me a point, so this is x1, y1. So I can plug that in already. Look at that, half credit already. Rolling. All I gotta do is find a slope. Now remember, this, I don't know the slope yet. This is not in the right form. If I want to find a slope of this, you gotta put it in y equals mx plus b form. Easiest way to find a slope is doing that. So this is, the slope is not 4. You gotta put it in the right form. So let's get that by itself. So I get, move that 4 over. Divided by 2. And y equals negative 2x plus 9/2. So my slope here is negative 2. And since it's parallel, that means we're using the same slope, so I'm going to use negative 2 here also. So I get y minus 4 equals negative 2, double negatives, x plus 2. And again, it didn't say anything about putting this in any form, so I'm just going to leave it like that. That's my answer. So that's parallel lines, right? Parallel lines have the same slope. So once you find a slope, use the exact same value. Next up, perpendicular lines. If you remember anything about them, they have negative reciprocal slopes. A lot of people say you have to multiply and get negative 1. I just think you flip it and you change the sign, right? Negative reciprocal. So you want to flip it and change the sign. That's what makes them perpendicular. So here, slope is 3. If we flip it and change the sign, we can get negative 1/3. Right? Or for example, if I say, hey, my slope is 1/5, the perpendicular slope is you flip it and then change the sign to negative 5. So let's look at this one. Write an equation of a line that passes through forward 2 and is perpendicular to that. So again, write an equation of a line. Every single time, just write this down. You get a little bit of credit because you understood what equation to use. And they give me a point. x1, y1. Just making it easy for me. All I gotta do is find the slope. And look at here. It's in the correct form. My slope is negative 2. Now, I want a perpendicular slope, so the one I'm going to use is not negative 2. It's actually going to find a negative reciprocal. Flip it and change the sign. So instead of a negative 2, it's going to be a positive 1/2. That's what goes here. Simplify a little bit. And there I go. Again, unless they specifically ask, that's my answer. So that's how you do perpendicular slopes, right? Again, if they want an equation of line, use this equation. Use a point slope equation every single time. Plug in your point, and then you got to find the slope. If it's perpendicular, negative reciprocal. If it's parallel, use the exact same value. In either case, make sure if they give you another equation to put in slope intercept form first. One final thing. Let's do this example here. Brad wants to send his girlfriend Kelly a dozen roses. He visits 2 stores. For what distance does the 2 stores charge the same amount to deliver roses? So first thing we're going to do is let's find an equation for both of these. So in this case, for full bloom, I like that title. It's a cool name. Dozen roses are $30. Delivery is $30 per mile. Right? So let's write an equation. $3 per mile, so that's my M. And then the roses cost $30. So my equation there is going to be 3x plus 30. Let's talk about Flowers R Us. They're going to get sued by Toys R Us, so don't invest stock. Y equals mx plus b. In this case, the dozen roses are $40. Whew. And but they only charge $2 per mile. So that's my equation there. Now there's a couple ways to figure out when they charge the same amount. So one thing you can do is you can graph them both, right? Graph full bloom, awesome name. So plus 30, slope is 3/1, graph something like that. You could graph Flowers R Us, kind of lame. So 40, slope is 2, so and you can figure out where they cross. So right there is where they charge the same amount. So that's one way to do it. Another way to do it is, well, I want to know when they charge the same amount. So what if I just set them equal to each other? Set this thing equal to that thing. And I can solve it that way. I do a little mathematics. Minus 30, minus 30, minus 2x, minus 2x. I get x equals 10. Now, x in this case was miles. Probably should have said that earlier. Or y was cost. So it'll be at 10 miles, or at 10 miles, they cost the same. So that's how I figure out if they cost the same. Now, actually, what if I changed it? What if I said, hey, what if I want to deliver, what if I live 5 miles away? Which one's cheaper? There's actually two ways you could do this. At 5 miles away, you just plug in 5 miles to each of them, right? Let's plug in 5 miles to both. I get 15 plus 30 is $45. And over here at Flowers R Us, dumb name, I get 10 plus 40, which is $50. So full bloom will be cheaper. You can also do this by looking at the graph, right? This was full bloom. This was Flowers R Us, right? So at 5 miles, full bloom's cheaper. Now, if I go more than 10 miles, though, which was our thing right here, let's say I live 15 miles away. In that case, Flowers R Us is actually cheaper. So there's a quick way to check this by looking at the graph, and there's another way looking at it just by doing the math. Anyway, that's it.